It is important to remind that all the interpretations in this example were right in a way, based on the available data, the only one seismic line. The different interpretation could equally explain the data. And that's in fact because interpretation is just a special kind of inverse problem. To close this section of the presentation, I will summarize what, in my opinion, is unique about geology. As I have said, it's not the method that characterizes geology. In this respect, it is like every other science. If there is anything unique about geology, it's that geology mainly deals with inverse problems. We can now define in more detail what is peculiar in geology. To do so, we can compare the work of a geologist to the one of a detective. As a detective, a geologist generates hypotheses to submit to the court, the rock in our case. What is peculiar of geology is quantity and quality of signs, fingerprints and remnants we find on the crime scene. In other words, unfortunately, the incompleteness and at the same time the complexity of the geological record make our job very difficult. Even Lieutenant Colombo would have problems to unravel the story of 5 murders happened in different time but in the same room. On top of that, another difficulty makes our job even more intriguing: the scale problem with experiment. Yet, despite all these limitations, geology is a science that applies the same scientific method used, for example, in physics. Geology is in no way inferior to the so-called hard sciences. The best example of this is oil exploration, the practical experiment being the well. Each dry well is a falsification of a model. I truly think the oil industry is the best example of scientific method applied to geology, and this is not only because of my job. But let's have a look to the normal workflow used in exploration. As we have seen, each interpreter has already a model in his mind. Ideally, the best way to approach interpretation will be to create as many models as possible. But due to time constraints, what can be done and what normally happens is that interpretation is refined through iterations to honor the available data and amended and updated to implement suggestions and comments from the peers. As we cannot create different models, it is very important to be open-minded, to test and to amend the model as soon as more data become available. Peer reviews are also very important at this stage. Suggestions and comments coming from peers with different backgrounds and experience can play the role of multiple hypotheses. Once interpretation has been performed, a conceptual model of the possible place in the area under exploration is generated and assessed. To do so, the explorationist generates a series of maps to evaluate the presence and quality of the play elements, reservoir, source, seal, and trap, and to evaluate the risk of something going wrong. It is a complex exercise taking into account generation and migration of the hydrocarbons, paleogeography of the area during the deposition of the possible reservoir, timing of the structuration, and so on. The result of this work is the definition of a sub-area where to focus with future work. The next step is to generate a prospect, meaning to invent a hypothesis about a single trap within the sub-area defined after the play analysis. What we have here is a very complex model formed by 2 different levels, play level and prospect level, and by the relationship between the two. Yet it is still a model, meaning a simplified version of the reality. In other words, reality is always more complex, and we will see a beautiful example of this later on.